All right. So in the last session, we started with IPv4, right? So we started with the discussion of IPv4. How many classes are there? We have class A, B, C, and we discussed that the classes are defined based on the number in the first octet of an IPv4. Right? And we know that an IPv4 is written in the form of A dot B dot C dot D, where all these alphabets are different numbers, but all these numbers may be same, may not be same, but they are 32 bits number, right? And the first octet of an IPv4 address is what we are checking when we are looking for the class of an IPv4 address. And we have five different class A, B, C, D, and E. A, B, C are the classes which we use most of the time. D is the multicast class, and E is the reserved or the experimental class, right? And then we started to discuss that each of these classes have different network octets and host octets, right? And we then discussed what is the significance of a network octet and what is the significance of a host octet, with the example of the world map, and with the example of the address of a resident, right? We discussed all that. So where in that network part in any IP address remains constant, whereas the host part keeps changing, right? This is what we had discussed. And then we discussed that the computers do not understand IP addresses. They understand only binary digits. So using the binary digits, how are they going to understand which is the network part, which is the host part, etc.? So for that, we use address mask, right? Address mask is usually for the networking devices to understand in an IP address which is the network part and which is the host part. So thereby, with that, the networking devices are also able to calculate if it's a class A, B, or C IP address, right? And we saw the default masks for all the different classes. And then we also just saw what do we mean by the range of IP addresses for each of different classes, right? So for class A, we just we took an example of 10 dot IP address, and then we saw what is the starting IP address and what is the ending IP address, right? And that is what you call as the range of IP address for class A. For similarly for class B, you will have a different range depending on the address mask, right? And moving on with that, today we'll discuss few like questions or few few mathematical things that we should understand to in order to get a better grasp on the IPv4 subnetting. Okay, so what we are going to check here is that what we are going to do an exercise today. So uh, before I jump on to the exercise, okay, let us discuss few things. So when someone says find the range of an IP address, we just saw how to find the range of an IP address, or we tried to understand what is the range of an IP address. Okay. So for example, when I said, give me can you see my screen?
Yes, sir. It's
Okay. So when we say, for example, an address like 10.0.0.0, okay, with an address mask of 255.0.0.0, in the last session we just took an example, right? That what is going to be the starting of this IP address range? The IP address would start from 10.0.0.0, and since 255, this corresponds to the first octet of the IP address, right? Only 10 would remain the same. The rest of the numbers in the octets will change. So the next IP address would be 10.0.0.1. And like that, it will go up till 10.255.255.255. This is the range of IP address. So basically, if in an interview question, usually in an interview question, they do not ask you questions like this. They may ask you, like, let's say, 100, okay, 100.100.100.1, okay, and the address mask is 255.0.0.0. Find out the subnet, or find out the network ID, and find out the broadcast ID for this IP address. In an interview question, they may ask you like questions like this, or even when you're giving the actual CCNA exam, you may find such questions, right? 100.100.100.1. What is the network ID and what is the broadcast ID for this IP address? Okay, so for such questions, okay, what you're supposed to do? I'm telling you the math here. Right? All you're supposed to do is just write down the IP address 100.100.100.1. Okay, and write down the mask, that is 255.0.0.0. Okay. Now to find the network ID. Now, what is a network ID? Network ID is the ID from where the IP address is basically starting. So in this example, this is the network ID. 10.0.0.0 is the network ID. Now, for this IP address, what is going to be the network ID? You're supposed to write that down. Okay. Now, when you're finding the network ID for this IP address, what you can do is wherever there is 255, wherever there is 255, okay, write that corresponding number as such, or copy that number as such. Okay, and wherever there is 0, write 0. Right. So this becomes your network ID for this IP address, meaning that this IP address was starting from 100.0.0.0, and all these numbers kept changing, and finally it reached to this number 100.100.100.1, meaning that the third octet started from 0, went to 1, 2, 3, 4, 5, 6, like that, and it went up till 100. Right? Similarly, the second octet started from 0, then 1, 2, 3, 4, and it ended at 100. Right? So we got this IP 100.100.100.1. So for this IP address, the network ID is this. And how did we calculate? Write down the address mask as such, and wherever there is 255 in the address mask, copy that value in the IP address as such. The rest of them, wherever there is 0 in the address mask, write 0. So this becomes your network ID. The next question is, find out the broadcast ID for this IP address. Find out the broadcast ID for this IP address. So all you're going to do is wherever there is 0, or wherever there is 0 here, right? Instead of 0, write 255. And this is your broadcast ID or broadcast address. 100.255.255.255. This is your broadcast address. So your IP address, this 100.100.100.1, is somewhere in between 100.0.0.0 and 100.255.255.255. It is somewhere in between here. So this is how you find out the network ID and the broadcast ID for a given IP address. Okay, so let's do some practical or some questions.
Lakshya sir, I have one doubt. Okay. So can you just go again to the whiteboard there? Yeah. So this trick will definitely help. But let's consider if they have provided some different subnet mask rather than 255. So is there any way to find this Easy.
I will come to that. Let's
Okay,
first
okay.
find out.
No, sir. Okay.
Yeah, let's find out first. Try to understand how these network ID and broadcast ID is created, or found out using this simple trick. Okay, where only 255 is there, where only 255 is present in the question. Okay. So let's do some questions. So now here, the first question. Okay, first question says the address is 1.1.1.1. Okay, so which class does it belong to? Which class
In
does it belong to?
class A,
Class A, right? How many network octets are there in class A? How many network octets are there in class A? Only first, right? It's class A. So one network octet, host octets, three host octets. Okay. Then find out the network ID. We know that this IP address belongs to class A. If it is class A, we know that the default address mask of a class A IP address is 255.0.0.0, right? We know this. Now to find out the network ID, what we are supposed to do, as I said, when we are finding out the network ID, wherever there is 255, copy that octet number as such. And wherever there is 0, write down 0. So this becomes your network ID. What is a broadcast ID? Convert these zeros or replace these zeros with 255. This is your broadcast ID. So your 1.1.1.1 is your 1.1.1.1 lies in between these two addresses, the network ID and the broadcast ID. And in a class A IP address, in a class, not just class A, any class, okay, the network ID and the broadcast ID are non-assignable IPs, meaning you cannot assign this to anyone. You can assign any IP address that is in between these two, like this one, 1.1.1.1. You can assign this IP address to any user in the network, but the network ID and the broadcast ID, these two IDs or IP addresses, you cannot assign to anyone. That is why, if you remember in the last session, I showed you the host numbers was always -2. Why was it a -2? Because we are not using the network ID and we are not using the broadcast ID, and hence it was -2 of the total number. Right? Any question with this first one? Okay, I take that as a no. Now, the second one is 128. Second one is 128.1.6.5. Okay. Now, which class does 128 belong to? Can someone tell me the class? Yep.
chat में डाला class B.
All right. Okay. Okay. So because I'm using a single screen, I cannot see the chat. Okay. So you will have to speak up. You guys will have to speak up. Okay. All right. As I said, I'm using only one screen, so I cannot see the chats. I can only see my screen over here. Okay, so it belongs to class B, right? And how many octets do we have in network? Network octets, 2. We also have 2 host octets, right? And we know that if you have 2 network octets, that means the default mask is 255.255.0.0. Right? Now we need to find out the network ID. We change the color. We need to find out the network ID. So to find out the network ID, as I said, all you need to do is Wherever there is 255, copy that value down, 128.1. And wherever there is 0, write down 0. This is your network ID. Okay. Now, to find out the broadcast ID, convert these zeros to 255. 128.1.255.255. So this IP address 128.1.6.5 lies between these two IP addresses. Somewhere here, in between these two IP addresses. Okay. Any question? I will not be able to read the chats. I see.
No, sir. No, sir.
Right. Okay. Now, next, let's take this one, fourth one. 192.192.1.1. Okay. This belongs to class C, 3 network octets and 1 host octet, right? And the default mask is 255.255.255.0, right? To find out the network ID, copy down all the values which has 255 as the address mask, right? So 192.192.1 and wherever there is 0, write down 0. So this is your network ID. And what is a broadcast ID? Change this 0 to 255. 192.192.1.255. This is your broadcast ID. Okay, so this IP address 192.1.1.1 basically is the first IP address in this range. 192.192.1.1 is the first IP address after 0. All right. Any question with this part?
No, sir.
No. I see messages on the chat. Okay. Now,
सर इसके अलावा भी और कुछ पूछते हैं क्या, लाइक होस्ट पोर्शन कितना है और
yes,
और
I'm
भी
coming to
कुछ?
that part. Yes, I'm coming to that. Now, if we use the default address mask, okay, that we have seen over here. Okay, so okay, so this default address masks, okay, for class A, class B, and class C. Okay, and you can see the number of hosts that we can have in class A, 2 power 24 minus 2. So in order to give you an example of what it would look like. So let's say that you are an internet service provider. Think of it or imagine yourself as the internet service provider. Now, some guy, a random company came to you, let's say company ABC. Company ABC approached you and he said he wants an IP address. Okay. So his condition is first, there are, let's say there are, for example, 1,000 employees. He has 1,000 employees in his company. He wants unique IP addresses for these 1,000 employees. Okay, that is his first requirement. Second requirement is that all his IP address should start with the IP number 10. That is his requirement. 10 should be the starting of any IP address for his 1,000 employees. This is his requirement. Okay. So you thought it's easy, right? You said it's easy. Okay, what I'm going to do, I will give you this address space 10.0.0.0 address mask as 255.0.0.0. So what is happening here? All the 1,000 employees who wants the IP address will get the IP address, plus all of them will have an IP address starting with 10. Okay, so let's say 10.0.0.1 is the first employee, right? Then the 255th employee would get 10.0.0.255, right? Then the 256th employee would get 10.0.1.1, sorry, or 1.0, right? Then 10.0.1.1 and up till 10.0.1.255, like this, right? So in such a way, what is going to happen? All the 1,000 employees will get an IP address. However, we know that the address range, not the address range, the host numbers in a class A IP address is 2 power 24. Where is 2 power 24 and where is 1,000? 2 power 24 is beyond our even counting things, right? That many you can get that many users or IP addresses. Now, what you did, you gave away all the address space for 10 with this address mask to just this guy, ABC, or the company. Okay. 2 power 24, I think is, let's check. I think it is around 100 crores if I'm not wrong. Let me just check. I am pretty sure we will not be able to calculate. 2 to the power 24. Ones, tens, 100, 1,000, 10,000, lakh, 10 lakh, crore. Okay. So my guess was almost right. It's around crores, right? Now, imagine this guy only has 1,000 employees. Okay, we gave away all the 1,000 IP addresses. What about the rest? It has almost 1 crore 16 lakh or 6 lakh. Sorry, 1 crore 6 lakh IP addresses, out of which we gave only 1,000. What about the rest of the IP addresses? It's going to be a complete waste, right? If I choose such IPv4 distribution, right, the IP addresses are going to go waste very quickly. Obviously, this company will never ever grow at a point where it has 1 crore 6 lakh employees. Which company has 1 crore 6 lakh employees in this, even in 2025? No company has 1 crore employees. It's beyond that, right? So anyway, even if he says I will get 1 crore 6 lakh employees in the future, it's not going to happen. So giving away all the address space just for this employee and wasting all the other addresses is of no use, right? And the designers of IPv4 address, they said it's not going to work. They immediately knew this is not going to work. So we have to come up with some solution where we can save the IP addresses and we can give only the IP addresses that is required by the customer. He wants 1,000 IP addresses and he wants IP addresses for starting with 10. We will give that, and we will give only the IP. We will give only 1,000 IP addresses. So what is going to happen? Your class A useless IP addresses are saved, right? And that process, that saving of IP addresses, so that the minimum wastage of IP addresses happens, is basically called as subnetting. Is what you call it as subnetting. So a big IP address space, you're giving only a small portion of that IP address space so that your IP address space does not go waste. That is called as subnetting. Okay. Now, in subnetting, what basically happens is that we break the rules. Whereas when I say break the rules, in class A, we know that a class A IP address will start from 1 till 126, and the default address mask is 255.0.0.0. For class B, the IP address will start from 128 till 191, and it will have a address mask of 255.0.0. Class C is going to be 192 to 223. Okay, 255.255.255.0. Okay. So this is the default address mask, right? Now, as I said, the guy wants, let's say a company comes to you. Let's take that example. A company comes to you and he says, I want only 200 IP addresses. I want only 200 IP addresses, and my address should start from 10. These are the two requirements. My IP, I want 200 IP addresses, and the IP address should start with 10. Now, if I go with my original IPv4 schema, I will have to use this, right? Where the IP address should start with 10. So obviously I will have to use class A IP address. But with the default address mask, I will only be able, I want only 200 IP addresses. But with default address mask, I cannot choose that. Now, in order to do this, the IPv4 engineers, they said, let's break the rule. Let's break the rule. Meaning that we are not going to go with class full address mask. So class full address mask means that the corresponding class A IP address will have the corresponding class A address mask. Class B IP address will have the corresponding class B address mask, and class C will have the corresponding class C address mask. This is called as class full address mask. Now, when such requirements came, they said, let's break the rule. Why can't I use a class A IP address with a class C address mask? Or why cannot I use a class C address number, class C IP address with class A address mask? Based on a requirement. So in this requirement, he said, I want 200 IP addresses starting with class A. Yes, so starting with IP 10. Right? So let's give him that 10.0.0.0, right? And he will have the address mask of 255.255.255.0. So what is going to happen here? Let's check the network ID and the broadcast ID over here, right? So 10.0.0.0, 255.255.255.0. So what is going to be the address mask? Wherever there is 255, copy that value down, 10.0.0. And wherever there is 0, 0. So this is your network ID. And what is going to be the broadcast ID? Convert this 0 or the last 0 to 255. 10.0.0.255. So your address is starting from 10.0.0.1 and it will go up till 10.0.0.255. So here, what is happening? The company wanted 200 IP addresses and we can give him 200 IP addresses plus the IP addresses are starting from 10, right? So what happened? We are using a class A IP address along with a class C address mask and saving a huge number of IP addresses. This is called as subnetting. And when you break the class full address mask rule, when you break the class full address mask rule, it is called as classless IP address. It does not have a class, classless IP, where the address mask and the class of the IP address do not match. Just like here, this is a class A IP address, but I'm using a class C address mask, and hence it is called as a classless IP. Any question understanding what is a classless IP address?
No, sir.
All right. Now, Give me, I'm looking for some problems. Okay, it's not. I wanted to show you some problem. I cannot find it out. Anyway, now in such scenarios, okay, if such scenarios also come, let's give me some random IP address, any random IP address. Vivek, Mohit, give me any random IP address.
172,
Okay.
29,
Uh-huh.
16 dot
Uh,
32.
33. Okay. Now, as I said, if we just simply look at this IP address, we know that this is a class B IP address. Right. This is a class B IP address. Now, for class B IP address, the default mask is going to be 255.255.0.0. This is a class full IP address, right? Now, let me make this as a classless IP address, but just changing this 0 into 255, where this is a class C address mask. So, even in this scenario, it is a classless IP address, where this is a class C address mask, but this is a class B IP address. And hence it's called as a classless. Now, in this scenario, if you are supposed to ask, if you're asked, what is the network ID and what is the broadcast ID? It's very simple. The way we did for classful, we will do it for classless as well. Wherever there is 255, just write down that number 172.29.16, and wherever there is 0, write down 0. This is your network ID. Now, to find out the broadcast ID, change this 0 to 255. 172.29.16.255 is your broadcast ID. Is your broadcast ID. Right? Now, in real world, okay, in real world, what happened was such kind of, you may not see such kind of IP addresses, okay, where everything is 255. Everything is 255. You may not see every time. You may see some different numbers. Okay, and what are those numbers? Let's go back to our table. Okay, so these are the numbers that you may find in an address mask. Okay, as I said, you will always have address masks where all the ones are on the left hand side and all the zeros are on the right hand side, right? So whenever you are writing an address mask, how does a computer identify which is a network part and a host part? By counting the number of ones, right? So 172.16 dot, sorry, 172.29.16 dot, what was the number? 32. Okay. How was the computer able to find out which is the network part and which is the host part? By counting the number of ones in the address mask. So you have 8 ones over here, another set of 8 ones, another set of 8 ones, and a 0. With this, it was able to find out that this is the network part and this is the host part. Now, there's a high chance. There is a high chance that you may not find 8 numbers, right? You may not find 8 digits in the or 8 consecutive ones. You may not find 8 consecutive ones in the octet. Okay, 8 consecutive ones from the left hand side. Let's say this is 1, 2, 3, 4. The rest are 1, 2, 3. Okay. Then again 1, 2, 3, 4, 5. Sorry. One, two, three, four. 1, 2, 3. These are 8. These are 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And here also there are 8 zeros. Okay. You may find such an IP address also, or an address mask also. So if you have 4 ones, okay, if you have 4 ones, that is 240. Okay, so you may have 172.28.16.32, and the address mask is 240.0.0.0. You may see such address mask also, or instead of this, you may see 172.28.16.32, and you may see 255 dot 255.224.0, meaning that there are 8 ones over here, then again 8 ones over here, and for 224, is my mouse, 224, 3. There are 3 ones for 224. Okay, so you may see then 3 ones over here, 3 ones, and the rest are zeros. Here also 0. Right. So what is, as I said, what is happening here? The computer, not computer, any networking device is only going to read the number of ones. And in an address mask, it is compulsory that the number of ones should be always on the left hand side. The total number of ones should be always on the left hand side. All the ones should come together. All the zeros should come together. You cannot have 0, 0, 0 here, then 0, 0, 0. No, it's not like that. All the ones should be on one side, and all the zeros should be on one side. Right. So if you get such number 255.255.224.0, that is also a valid address mask. Now, in such a scenario, how are you going to calculate the number of hosts? How are you going to calculate the number of network part? What is the IP subnet? What is the IP range? What is the network ID? What is the broadcast mask? Everything that also needs to be understood. Okay, before I move on, any question up till this part?
No from mine.
No, sir.
So when you basically break the classful rule, when you break the classful rule, it is called as a classless. Or basically what you do is basically you are dividing a big network into smaller sub parts, or basically smaller subnets. That is how the word came, subnets. You are dividing a bigger network into smaller parts, subnets, subnetworks. All right. So when we are talking about subnets, right? When we are talking about subnets, we are basically dividing a bigger network into smaller parts, which is called as subnets. Now, to understand subnets easily, we have to understand few things. We have to understand few things. Now, and what are those few things? When you divide a big network into subnets, the whole IP address is then divided into 3 parts. Till now, we saw the IP address gets divided into 2 parts, the network part and the host part. But when you are actually dividing it into a classless IP address, or a subnet IP address, the whole IP address gets divided into three parts: the network part, subnet part, and the host part. These are the three parts it gets divided into in a classless IP address. Classless IP address. A network part, a subnet part, and a host part. Okay. To visually understand this, let's open the PDF over here. Okay. So if you see here, what you're basically doing, this is your this is your host part, sorry, the network part, where you can see the number of ones, masks with 1. This is your host part with all the zeros, right? And you can see this is a class C default mask where all you have is the number of ones and all you have is the number of zeros on the right hand side. Now, when you are subnetting, what is actually happening is a third part comes into picture, which is called as the subnet part. So basically what happens, your network part, okay, network part is basically including the subnet part. Or what happens, the yeah, okay. So what happens basically is in the network part, in the subnet part, you are basically borrowing the zeros from your host part and converting them into ones. Again, let me repeat. When you are making a classless IP address, you borrow some bits of zeros from the host part and convert it into 1. And we know that the networking devices understand ones as the network part, but we know that in subnetting or in a classless IP addresses, the borrowed zeros, the number of zeros that you borrowed and converted them into ones, those bits are called as subnet bits. Those bits are called as subnet bits. Let me again visually show you that part. Okay, so over here, see this. Now, here you can see the address is 10.1.1.0. The mask is 255.255.255.0. We know that this is a class A IP address. If it is a class A IP address, this is supposed to be not 255, but this is supposed to be 0, 0.0, right? So here, basically, all of these numbers should be 0. All these ones should be 0. But when we are doing a classless or subnetting, what we are doing, we converted this, all these zeros here, all these zeros, right, into the number of ones, or basically we borrowed those zeros from the default address mask and converted them into ones, right? We converted them into ones. So when we convert the borrowed zeros, how many zeros did we borrow from the default address mask of class A? We borrowed 16. We borrowed 16 zeros from the default address mask of class A and converted them into ones. So you have 16 bits of subnet. You have 16 bits of subnet. So in total, your subnet plus your network bit, subnet plus your network bit gives you the total number of ones, which is also called as prefix, I will explain this once again if you're confused. This address mask, we know that this IP 10.1.1.0 should have a default address mask of 255.0.0.0. But you can see this is a classless address mask where 255.255.255.0 is the address mask. And we know that 255 means there should be one, there should be 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. So we converted all the zeros in the second octet. There are 8 zeros in the second octet. We converted them into ones. There are 8 zeros in the third octet. We converted them into ones, making it 255.255.255. So basically what we are doing, we are borrowing or we are converting the zeros from the host part. Please remember this. We are converting zeros from the host part and making them or changing them into 1. Now, the number of bits or the number of zeros that you converted, the number of zeros, please remember, the number of zeros that you converted is called as the subnet bit. And here in this example, we borrowed 8 plus 8, 16 bits of zeros, or we converted 16 bits of zeros into ones. And that is why the subnet bits is 16. So your subnet, 16 bits of subnets and 8 bits of network, that was already the part of class A, right? So in total, 8 plus 8 plus 8, that is 24. So this is your network bit, which is 8 bits, the original 8 bits, plus your subnet bits, the borrowed bits, which gives you the prefix. We call this total number of ones in subnetting as prefix. Total number of ones is called as prefix. Any question? Any difficulty understanding this part?
Yes, sir.
Yeah, tell me.
सर एक बार फिर से आप एक्सप्लेन कर सकते हो?
Which part?
सर वो बोरोइंग वाला पार्ट, वो लाइक मतलब होस्ट क्यों बोरो करेगा?
So let's take this example 10.1.1.1. Okay. What is the default address mask? 255.255, sorry, 255.0.0.0. Okay.
Yes.
Now, if I give away this IP address space, how many hosts am I giving away? I'm giving away 2 power 24 minus 2 hosts. Correct?
Yes.
I'm giving away 2 power 24 minus hosts. The host part is the 0 part. 0 parts are called as the host part, right? So if I want less number of hosts to be given to the customer, I have to reduce the number of zeros.
Yes.
Right? If I have to reduce the number of zeros, that means I should have more ones into the section. If I want more number of ones into the section, what am I supposed to do? I will obviously have to convert the zeros in these parts into ones. then only the number of zeros in this part will reduce. So you have 255, 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. Now, I do not want these many hosts to be given away because I know it's going to be of no use. There are a lot of IP addresses, there are a lot of IP address space that is going to be a waste. So I need to reduce the number of zeros in my address mask. If I want to reduce number of zeros in my address mask, I need more number of ones. How will I get more number of ones? Until and unless I change each of these zeros to ones, I'm not going to get more number of ones. Plus, my zeros are not going to reduce. That is what I meant. Borrowing. You're borrowing the zeros in the actual host part. This is the actual host part, right? With number of zeros. You're borrowing these zeros from the host part and converting them into ones. So you converted 8 zeros to ones. So thereby reducing the number of zeros and increasing the number of ones. So previously there were only 8 ones. Now there are 16 ones. Right? Previously
Yes.
there were 8 ones and 24 zeros. Now you have 16 ones and 16 zeros. So what is happening? Previously there were 2 power 24 minus 2 hosts. Now there are only 2 power 16 minus 2 hosts. Now if you want to decrease even more hosts, you convert those zeros. You convert those zeros. So now you have 24 ones and you have 8 zeros. So basically you only have 2 power 8 minus 2 hosts. So what happened? Your usable IP address range without wasting too many IP addresses is getting saved. This is what we call it as subnetting. And the number of bits that you convert to ones are called as the subnet bits. So you converted 16 zeros to ones. So basically you have 16 subnet bits. Now, when you have 16 subnet bits, that means you have 16 number of ones. 16 number of ones plus this 8 already existing ones. So 16 plus 8 gives us 24. This is called as the prefix. The total number of ones is called as the prefix. Total number of ones. Total number of ones will include your network part, network bits, as well as the subnet bits. Is this clear now?
Yes, sir.
Mohit?
Yes, sir.
Not
Yes.
Mohit, sorry. Vivek?
Sir,
कोई doubt इसमें?
that
Yeah,
is
yeah,
why we write like IP and besides that /24.
exactly.
Yes, sir. Now it's clear. So we are doing this like we are converting these zeros so that we can reduce the wastage of like IP addresses, and we can like increase the subnet bits and we can make them reusable. I mean, we can avoid wastages. So that is
Right.
why we are doing this.
Subnetting, yes.
Okay, sir.
Now, let's take the same example. As I said, when you are working with subnets, and as I said, in a address mask, all your ones are on the left hand side and all your zeros are on the right hand side. You can see this in this example, correct? Now, if I want all my ones on the left hand side and all the zeros in the address mask on the right hand side, obviously I do not, and there are many times where I will not convert all these zeros in a particular octet. Let's say this is one, two, let's say this is all ones, right? Here I will convert, let's say, all these to ones, 1, 2, 3, 4, 5, 6, 7, 8. But here I will only convert these two as ones. The rest of them are zeros. So what is happening? This part becomes your host part, and this becomes your network plus subnet part. However, I converted only two zeros to ones. So how many subnet bits are there? 8 plus 2, 10. 10 subnet bits plus 8 network bits, giving us 18 as the prefix. Right? 18 as the prefix. Now, let's convert this into its decimal form. Let's convert this into its decimal form. So we know that all ones is 255, right? Plus this is all ones, this is 255. And here you just have two ones. When you have two ones, this is 192, then dot 0. So this is your address mask now. 255.255.192.0. This is your address mask now. Is this clear? How we got 192 over here? And as I said, in real time, you may see IP addresses where it's not 255, it's some other number. And that other number is from this table only. From this table only. It will be 128, 192, 224, 248, 248, 252, 254, or 255 only. Okay. It will be any other number than these. It cannot be any other number than these. All right. So, and when you're, as I said, when you're writing an IP address, all your ones should be on the left hand side, just like this. All the ones shall be only on the left hand side. Now I cannot write this as 1111. All are 1111. That is okay. 1111. Here 192, 1, 1. Then all are zeros. 1, 2, 3, 4, 5, 6. Right. Then I cannot write 255 over here. 1, 1, 1, 1, 1, 1, 1, 1 like this. It cannot happen. This is not the right way of writing the address mask, because you have zeros in between ones. This is not the address mask. So the moment you start writing zeros in the address mask, all the other digits should also be 0. Then only you will have everything on the left hand side as 1, everything on the right hand side as 1. So now if you're writing this as the address mask, it will be 255.192.0.0. This is also a valid address mask. This is also a valid address mask. Okay, clear? Any problem? Understanding subnetting, what is subnet bits, what is a network bit, and what is a host bit, and what is a prefix. Any problem understanding this?
No, sir.
Now let's do some practice. So let's try to understand few questions. All right. So here, first thing, he says, this is your IP address 8.1.4.5, and this is the address mask 255.255.0.0. our aim is to find out what is the prefix, that is subnet bits plus your network bits. What is the prefix bit? Then how many subnet bits are there? How many network bits are there? How many host bits are there? Okay, and total number of subnets and total number of hosts. This is what we are looking for now with this IP address and this address mask. Okay. So the question says, this is your address mask. Sorry, this is your IP address and this is your address mask. Find out the prefix, find out the network bits, find out the subnets, right? Find out the host bits, find out the total number of subnets, and find out the total number of hosts. Okay, this is the problem. Now let's try to solve it. 8.1.4.5, 255, 255, 255, right? Now we know that 8 is a class A IP address. So we already know network bit is going to be 8. We are confirmed. Network bit is going to be 8. And with network bit, we already know what is going to be the default mask. That is 255.255.0.0.0, right? But the address mask over here is given as 255.255.0.0. So how many ones did we convert over here? How many zeros did we convert to number of ones? We converted 8, right? That is why we have over here. So you have 8 ones over here, 8 ones over here, 0.0. So this 8 is already part of your network bit. This is your subnet bit. So how many subnets bit do we have? We have 8 subnet bits. So in total, you have 16 bits of prefix number. Or in other way, what you can do is, we know that this is a class A IP address. So network bit is going to be 8. How many 8 do we have here? 255 plus 255. 8 plus 8, 16. We know that P is 16, right? If P is 16, how many subnet bits are there? Subnet bits. That is 16 minus 8. Or as I said, P is equal to network bit plus your subnet bit. So if you're trying to find out subnet bits, that is P minus N is equal to subnet bits. Very simple calculation. Let me tell you that once again. Total number of ones in the address mask. Total number of ones in the address mask is called as prefix. Right? So over here, you have 16. P is equal to 16. Then this is a class A IP address. So obviously you will have 8 network bits. So what is going to be the subnet? P minus N. That is 16 minus 8. And you have the total number of subnet bits as 8. Total number of subnet bits as 8. How many subnets will you have? How many subnets will you have? So total number of subnets is equal to 2 power s. So 2 power 8 is your total number of subnets. Clear? Total subnets is 2 power 8, not total subnet bits. Total subnet bits is 8, but total number of subnets is 2 power 8. Just like we calculate the host 2 power h, 2 power 24, right? Similarly, you have 2 power s bits. That is your total number of subnets, 2 power 8 subnets, right? Now, how many hosts do you have? We already know the total number of ones that we have, or P is equal to 16. And in an IP address, we have 32 bits. If there are 16 number of ones, then there should be 16 number of zeros also. Correct? 16 number of zeros also. So with this, we found out P is equal to 16, network bit is equal to 8, subnet bits is equal to 8, right? Then host bit is equal to 16. Total number of subnets is equal to 2 power 8, and total number of hosts is equal to 2 power 16 minus 2. We know that this minus 2 is for the network ID and for the broadcast ID. Any question? Clear?
Yes, sir.
So let's move on to the next part over here. It says 200.1.1.1. The address mask is 255.255.255.252. Okay, so with this, we already know 255 is 8 number of ones, 255 is again 8, 255 is again 8. So 8 plus 8 plus 8, 24. Now 252 is 6, 6 number of ones, 6 number of ones. So in total, P is equal to 30. Your P is equal to 30, right? Now we know that 200 is a class C IP address. So your network bit is going to be 24, right? So your subnet bits is P minus N, right? 30 minus 24, giving us 6. So your subnet bits is 6. Now, how many subnets can you have? Total number of subnets is equal to 2 power 6, right? And total IP bits are 32. We already have 30 number of ones. So how many hosts do you have? Or zeros do you have? You just have 2 zeros. That is your H. So total number of H is going to be 2 power 2 minus 2. You can see here, total number of hosts is 2 power 2 minus 2, and 2 power 6 is the subnets. We saw that 2 power 6 is the subnets. Clear? Any question? Understanding this part?
It's clear,
All
sir.
right. Yeah. All right. Now, when we say subnets, what do we mean by that? I'll give you a good example. What is the significance of subnetting? See here. Let's check this part. Okay. So this IP address is 172.16.0.0, right? 172.16.0.0. We know that this is a class B IP address. So network bit is 8, right? Address mask is 255.255.255, right? So total number of P is equal to 24. So subnets is equal to, sorry, this is not network part is 16, class B, so 16 network bits. So subnet bits is 8, right? So total subnets will be 2 power S, 2 power 8, right? So 2, 4, 8, 16, 32, 64, 128, 512, right? So you have 512 subnets. Or did I do this wrong? This is 64. 128. Starting from 2 power 0, right? Yeah, okay. 1, 2, 4.
So 256.
32, 64, 128 actually. Starting from 2 power 0, not 2 power 1. 120. So you have total 128 subnets. Right. Now P is 24, IP is 32. 32 minus 24, it gives us 6. 2 power h, right? 2 power 6 minus 2, correct? 128, 64, 32. So 30 total h is 2 power 6 minus 2. So we have 30. Now what does this mean? Total subnets and total hosts. What does this mean? So one subnet, one of your subnet. Okay, so 172.16.0.0. Let's try to find out the network ID and the broadcast ID, right? 255.255.255.0, right? So you have 172.16.0.0 as the network ID and 172.16.0.255 as the broadcast. Now, what does this mean? What is the significance of this? So if you see here, I hope you're getting this point. First, with this IP address, okay, let us go from this start. With this IP address, let's try to find out the number of what is the network ID and what is the broadcast ID. Okay.
Yes, sir.
One 172.16.0.0.255.255.255.0, right? What is the network ID? 172.16.0.0. Wherever there is 255, just copy down that value, because here it is also 0. We are copying that value again. So this is your network ID. What is the broadcast ID? 172.16.0.255. This is your broadcast ID. Okay. Now, second part, using the same thing, find out the total number of subnets and total number of hosts per subnet. Total number of hosts per subnet. Now, let's try to find that out. So we found out that with 172, the address mask is 255.255.255.0, right? So prefix total number of ones is 24. We know that 172 is a class B IP address, so 16, right? So subnet is equal to 24 minus 16, giving us 8. So total number of subnets should be 2 power 8, that is 128 subnets. And total number of hosts, we know that 32 is the total number of bits, and we already have total number of ones is 24. So you just have 6 left, that is 6 number of zeros, right? So your host bit is equally 6, but 2 power 6 minus 2, that gives us 30. Now
Sir,
what is the
6.
starting
Sir,
from 0, buddy, starting from 0, 2 power
okay,
0,
okay,
2
okay.
power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6. So 2, 4, 2, 4, 8, 16, 32, 64. Yeah, you're right. 64. I'm absolutely sorry. 64 minus 2 gives us 62. Okay, you are absolutely right. Thanks. 64, 128. This should be 512. 512. So 512 total number of subnets and 62. 64 minus 2 gives us 62. 62 hosts. What does this mean? with the network ID over here and the broadcast ID over here, and total number of subnets as 512 and total number of hosts per subnet as 62. What does this mean? This means that, let's go back over here. This is your first subnet. This is your first subnet starting at 172.16.0.0, ending at 172.16.0.254. The broadcast ID is 255. That is what we just saw. The broadcast ID, network ID is 16.0.0.0. Broadcast ID is 255. This is just the first subnet. This is only the first subnet. Okay, what is the second subnet? Second subnet will start where this 0 will then become 1. Right? 1. 172.16, 1.0. The first usable IP address is 1.1. It will go up till 1.254. Then the third octet will change to 2, then 3, 4, 5, 6, like that. And it will go up till it will have total 512 subnets. Is it 512?
Sir, 2 power 8. 2 power 8 is 256.
I think so. I'm making a mistake there. 1, 2, 4, 8, 16, 32, 64, 228, 256. 1, 2, 3, 4, 5, 6, 7, 8. I'm again. Sorry, my bad.
Yes, sir.
256. All right. So starting from, if we see here, starting from 0 and ending at 255, how many subnets do we have? 256 subnets. We have 256 subnets.
Yes, sir.
Right. And five, 6 over 6. And in each of these subnets, right? In each of these subnets, there will be 62 usable IP addresses. 62 usable IP addresses. Starting from 1 up till 62 will be the usable IP address.
Yes, sir. Sir, then what about the 2 IP address?
The rest of the see, after 62, from 63
Yes.
up till 254, these are also subnets, but he has omitted it. In this diagram, it is omitted to make things simpler.
Okay, sir.
Right. So you will have 255 such subnets. And in each of these subnets, you will have 62 usable hosts. 62 usable hosts. This is what it means. We will look into these problems in our next class, that is tomorrow. How to find out the usable IP addresses when you have such kind of IP address mask. How many subnets will be there, right?
Yes.
Where will the subnet start? Where will the subnet end? What will be the next subnet? Where will that subnet go up till? Everything. We will discuss this in tomorrow's class. But before I end this class today, any doubt understanding what is subnet?
No, sir. I am clear.
All right. Vivek?
Vivek actually dropped.
Okay,
It
no problem.
dropped off.
No problem. All right.